Alright, so today we're going to do two things. We are looking to find coefficients of terms in a binomial expansion without Pascal's triangle, and then we're going to use that method to help us expand a binomial as well. So those are the two things we're looking at. So in this first problem, we have the binomial x plus y to the 12th power, and we are interested in finding the ninth term, the coefficient of the ninth term, if I were to expand it. Okay? So first of all, how many terms does this thing have, by the way? 13. It has 13 terms, because remember, it's always one more than your exponent. Okay? So we're interested in finding the coefficient of the ninth term. So I could use Pascal's triangle and go all the way down to 12 and then go over to the ninth term and get that number. Okay? But there is a quicker way, a little bit quicker way to figure out what that coefficient is. Now, it's going to take us a while to do it the first time because I have to explain it, so you're not going to think it's faster. But once you understand what's going on, it's a little bit faster. Okay? So, first thing I want to do is label which coefficient it is we want to find. So we label it with a C. So I'm interested in finding the ninth term, the coefficient of the ninth term. To do that, we need to put two numbers underneath the C. The first number that goes on the left side of the C is whatever my exponent is. So my first number is going to be 12. Okay? The second number is going to be whatever your term is minus 1. So 9 minus 1 tells me the other number is 8. Alright, and then we're going to use the formula n with this exclamation mark. I'm interested if anybody knows what it means. Over n minus r with the exclamation mark, and then times r with the exclamation mark. What is that exclamation mark?
It's factorial.
Factorial. Very good. So this is n factorial over n minus r factorial times r factorial. Now, what does factorial do to a number?
Multiply that number by every number descending from it.
Okay, so for instance, if I had 6 factorial is the same thing as 6 times 5 times 4 times 3 times 2 times 1. That's what factorial does. Okay, so instead of writing all these numbers multiplied out, I can get away with writing it as 6 factorial. So that's what that factorial means. Okay? So in our case, this is my formula. The 12 is the n, and the 8 is the r. So first number is the n, and the second number is your r, and then I just plug it into my formula. So on the top, I'm going to have 12 factorial. On the bottom, I have n minus r, which gives me 4 factorial. And then I have r factorial on the right, which is 8 factorial.
Can you go over that again? Oh, wait. Second number's r.
I have n and r.
Oh, okay.
So I put n and r here, and then I subtract the 2, and that goes there. Okay, so n's on top, r is on the bottom, subtract the 2, it's also on the bottom. So those are the three numbers you have. Biggest one's on top, other one's on bottom, subtract the 2, that goes on bottom as well. So that's the quick way to do it. Alright, now, I want us to be able to simplify this as much as possible without putting it in our calculator. And there is something that cancels nicely for us.
4.
Not 4. We want to cancel, you always want to cancel the biggest number on the bottom.
8.
So we want to cancel out 8 factorial with the top. If I cancel out, now I'm just interested to see if anybody knows what it would end up with. If I cancel out 8 factorial with 12 factorial, what's left? Not 4. What is left would be 12 times 11 times 10 times 9. That's what's left on the top. Why is that what's left?
Because you're taking out the 8 through 1.
Right. The 8 factorial represents 8, 7, 6, 5, 4, 3, 2, 1. So if I take out the 8, 7, 6, 5, 4, 3, 2, 1 out of the 12, I'm left with 12, 11, 10, and 9. Everybody follow? So you're always going to cancel out whichever one is your biggest number. Okay, and then you're just going to peel off until you get to the number right in front of that number. So 12, 11, 10, 9, 8 would be next, so I don't need to write 8. So on the bottom, the only thing left is 4 times 3 times 2.
You never
You don't have
one?
one?
There is a 1 there, but do I need to put 1?
No.
No, I don't.
You just answered my question with a question.
So the next thing I want to do is take the 4 and the 3. What are the 4 and 3 combined to? 12. So I'm going to cancel that with the 12, and then I'm going to cancel the 2 with the 10 and get 5. So the only thing I have to multiply is 11 times 5 times 9, which should be 495.
Is that our answer?
So what does 495 represent?
The coefficient of the ninth term.
The coefficient of the ninth term of this thing expanding is what we found with 495. Carly, what was your question?
Okay, so you just cancel out the 12s, then you have 11 times 10 times 9 all over 2. How did you cancel the 10 and the 2?
Because 2 goes into both of these. So 2 goes into 2 one time, 2 goes into 10 5 times. So I canceled the 2 and the 10 and left the 5 on top. So 495 is the coefficient of the ninth term of that binomial expanded. Yes.
Can you not take like a factor out a 2 as like the 12 over 4 times 8? Can you not like factor out a 2 so it'd be like 6 over 2 4? Or does that not work out?
Say that again.
Like if you took that whole thing and divided it by 2,
Right here?
yeah, or divided it by 4 even, would that not work out? Because that's what I thought we were going to do, and then we took the 8 out.
I don't think it's as clean. I think
Okay.
that's more confusing. I think it's the easiest way is to always take the biggest one.
Okay.
I think that's the quickest way to do it. All right, let's try another one. This one should go quicker. Now that we know what we're doing. So I have 2p plus 1 to the 15th power. 2p plus 1 to the 15th power. I'm interested in finding the 11th term. So I always like to do that C and then put those two numbers underneath it. What two numbers would be underneath it? 15 and 10 is what should be down there. Everybody understand where those two numbers come from? Okay. Then on my fraction, 15's always on the top, 10's on the bottom, and what's the other number I need on the bottom?
10.
5. Okay, you can do that real quick. The left one goes on top, the right one goes on bottom, and then what's the other one? It's always those two subtracted. So you can always fill that out pretty quick. Okay, once I have those, then what do I want to cancel out?
10.
I want to cancel out the 10 factorial. So what's left on top? On top? 15 times, 14 times, 13 times, 12 times, 11.
Oh wait, how'd you cancel out the? Oh, okay.
And then on the bottom, I'm left with 5 times 4 times 3 times 2. Alright, so let's see what we can cancel here. What is 5 times 3? 15. So I'm going to cancel out the 5 and the 3 with the 15.
You can do that.
You can do that. What property allows me to do that? To consider the 5 and 3 together, be able to multiply those together. What? Commutative. Commutative property allows me to switch the order there. Alright, what else do you want to reduce in there?
12.
12 and the 4, which leaves me with the 3, and we can do one more reduction.
The 2 and
The 2 and the 14 gives me a 7. So I'm interested in 7 times 13 times 3 times 11.
How did you do the 5 and 15 again?
I did the 5 times the 3, which is 15.
Oh.
So I did the 5 and the 3, cancel out the 15. So what is 7 times 13 times 3 times 11?
3003.
3003? Now, what? Now, is 3003 my answer?
No.
No, why is that not my answer? And it was the last time. Because there's a 2 up there. There is a 2 up here, so I have to figure out what number the 2 is going to give me.
Oh, so you still have to multiply by 2?
I still have to multiply it. It's not just by 2. I have to figure out 2 to what power is it going to be. Okay, so here's what we have to do. I need to think about what exponent this 2p would have on the 11th term, and I need to figure out what exponent the 1 would have on the 11th term. And it's very easy. Whatever these numbers are down here at the bottom, those are the exponents of those two. So that means it's going to be 2p to the 5th. So I'm going to have 2p to the 5th, and then I'm going to have 1 to the 10th.
Can you, whatever the bottom numbers are, the first fraction, that's what it is?
Right here. Yeah, when you write the fraction right here, whatever these two bottoms numbers are, those are my two exponents. So that means to get the coefficient that I'm looking for, I need to do 2 to the 5th times 3003. So somebody do that for me. Just a second. Say it again. 96,096. And 96,096 will be my answer. That's the coefficient of the 11th term. Yes.
What do you do with the p?
Yeah, there's,
I really don't care about the p. All I care about is the coefficient, which is just the number in front. That's all we're trying to find right now is the number in front.
I'm lost.
All
What
right.
did you do with the coefficient 2? Does that have to do with anything? Just that
Yes.
you have to do that?
Yes. I had to figure out I needed to go 2 to what power? And that's where the 5 comes in. I had to do 2 to the 5th and then times 3003, and that's where this number comes from.
Why did you put a 1?
Because that's what this is.
So 1 to the 10th.
1 to the 10th is just 1. But I was putting it there so you would know where these exponents go.
Got it.
Okay? And my exponents, how do I get my exponents? It's always the two bottom numbers of my fraction. So I take these two, those are the exponents, I multiply that out, that gives me the coefficient I'm looking for.
Times.
Alright, let's do one more before we get to a full expansion.
What?
So this one I have 2x minus 3y to the 8th. I'm interested in the coefficient that goes in front of x to the 3rd and y to the 5th.
Does that say to the 8th?
Yes. 2x minus 3y to the 8th. I want the coefficient that goes in front of x cubed and y to the 5th. So, what's the top number of my fraction?
8.
8. What are my bottom two numbers?
3 and 5.
3 and 5. Very good. How did you know that, Lainey?
Because it's the power of the exponent.
Right. Remember, the power of the exponents, this right here and this right here always match up. So the bottom of your fraction and your exponent powers always match up.
How do you,
So,
what?
You didn't have to do that subtracting.
right, I didn't have to do it because as we found out on the last one, the bottom and the exponents always match. So I already knew what the bottom was.
Wait, but the exponents on the last one didn't match. Because there's only.
Right here. I have 5 and 10. And then I had 5 and 10. They gave it to me in a different way. This time they're telling me what these two things are, and I'm using it to find this. On this one, I knew what these were, and I used those to find that. So it's the reverse of what we did on the last problem.
So, how do you find. Okay.
Brock, what's your question? What was your question that you figured out?
I was confused where you got the bottom of 10, but you just got it from the bottom.
Correct.
5 and 10.
On the last problem.
No. I don't even see 10.
So which term is this actually?
The 5th. No, the 6th.
It's the sixth term. How do you know it's the sixth term?
Because 5 plus 1 is 6.
Because, yeah, this right here is always one less than your term. So that means this right here represents the sixth term. Alright, so what do I want to cancel out at this point?
5.
I want to cancel the 5 out. So what does that leave me with in the top?
8, 7,
8, 7, and 6. And on the bottom I have
3, 2.
3 times 2.
Take out the 6.
So the 3 and the 2 cancels with the 6, and we get 56. Okay, so what do I need to raise 2 to? 3. And what do I need to raise the negative 3 to?
The fifth.
The 5. Everybody okay with that? So now multiply that out for me and tell me what we get. What do you got? 864. So we end up with negative 108,864.
I got negative 1,000.
So what does negative 108,864 represent? The coefficient of x cubed y to the fifth, which is what term? The sixth term. Because the term is always one more than what that is. Alright, now we're going to use that approach to expand a binomial. Okay, we're going to do what we did yesterday, except we're not going to use Pascal's triangle to do it. We're going to do what we're doing today to do it. So, last example. So we have 3x plus y to the 7th. We want to expand this without Pascal's triangle.
Two.
So, any ideas of what we want to think about first? How many terms? Excellent, Isabella. And how many terms are there? There are 8 terms. Very good. That's good. Exponent of 7. There's always one more term than your exponents. Excellent. So the first thing I'm going to do is give myself 8 spaces. I'm going to give myself 8 spaces. And there are some of those spaces we should already know the numbers to.
The first and the last.
First and the last are always 1. First and last are always 1. There are 2 more that I know the numbers to. The next 2. What are the next ones? Right now we're just doing the coefficients. Okay, I want to get the coefficients first, then we'll come back and get the rest. So, I know the second one and the next to last. What are those 2? Those are 7s.
I didn't know that.
Because remember, the second one, and the next to last are always
The same numbers.
whatever my exponent is. Okay? So, how many of those spaces do I need to find now?
4.
Not 4.
2.
2.
Because the last one.
Because remember, this thing mirrors itself. So if I find these 2, I automatically know what these 2 are. So that means I need to find 2 coefficients. So let's label this first one. What are the 2 numbers that go underneath my C?
N and R.
N and R. So the N is going to be 7. What would the R be?
6.
2.
2.
That was one less.
1 less than the term. And this is the third term, so that means this has to be 2. So that means the other one needs a 7 and a 3. Yes, now we're going to use the formula we just got to figure out these 2 numbers. So I'm going to do the first one first. So I know a 7 needs to be on the top. I know a 2 needs to be on the bottom. And what's the other number that needs to be on the bottom? 5.
Oh, because you did 7 minus 2.
Correct. Okay, what's going to cancel? The 5, and what does that leave me with on the top?
7, 6.
7 times 6 over 2.
And then the 2 and the 6 cancel.
2 and the 6 cancel, gives me a 3, so that means my number is 21. So if that one's 21, what else is 21? The one beside the other 7 needs to be a 21.
You don't have to do that 3.
We're going to get there in just a second.
Oh wait, you stop at the 6, you
Wait,
need
do
to
you
get
not
rid
have
of
to do
5.
what?
Say it again.
You stop at the 6, you need to get rid of the 5.
When I get rid of the 5, yes, that causes me to stop at the 6 on the top. You always stop at the one before what you just canceled. Okay, so on the other one, I'm going to have a 7 on the top. I'm going to have a 3 on the bottom, and what are the numbers on the bottom?
4.
4 is on the bottom. So this time we're going to cancel the 4, which means I have 7 times 6 times 5 on the top, and I have 3 times 2 on the bottom.
Cancel those two with 6.
The 2 and the 3 cancel with the 6, so my number is
35.
35, which means the other number has to be 35. We're getting ready to do that. So the first thing you want to do is figure out how many terms there are and get all your coefficients. Okay, so if I were to use Pascal's triangle and I went all the way down to the 7th, those are the numbers I would get. But we want to be able to do that without Pascal's triangle. Okay, so now I need to do the rest of it. So now we need to fill in the rest of it. And I'm going to take this one piece at a time. So let's just look at the 3x first. So what does my 3x need to be right here with the 1? 3x to the 7th. I'm going to write it just below and make it 3x to the 7th. The next one needs to be 3x to the 6th, and so on. So 3x to the 5th, 3x to the 4th, 3x cubed, 3x squared, and 3x. All right, then we need to take care of the y's. So where does the y start at? The second one. So it's going to be y, y squared, y cubed, y to the 4th, y to the 5th, y to the 6th, and y to the 7th.
So the last one doesn't have anything?
Right. Doesn't have anything on it except just the y to the 7th. Now it's just a matter of multiplying everything out. So my first term is going to be 3 to the 7th and then x to the 7th. So somebody do 3 to the 7th for me. 2,187? Okay. Then what do I need to do on the second one?
How did you get that?
I did 3 to the 7th.
Oh.
You gave me that. So on the next one, I need to do 3 to the 6th and then take that answer times 7.
Y times 7.
Because that's my other number I have to use. This one just had a 1. So 5,103. So that's going to be x to the 6th, y. Okay, so the next one I need 3 to the 5th times 21. Anybody? Yep. Same thing again?
Yeah.
5103. So that's x to the 5th, y squared. So now I'm on 3 to the 5th, 3 to the 4th times 35. 2,835. And that is, which one are we on? The 4th one, so that's x to the 4th, y to the 3rd. So then the next one is going to be 3 to the 3rd and 35. When we get there. 945. So that one is x to the 3rd, y to the 4th. All right, then I need 3 squared times 21. 189. So 189x squared y to the 5th. Then we need 3 times 7, which is just going to be 21. So 21x y to the 6th. And then the last one is just y to the 7th. So if I take 3x plus y to the 7th and I expand it, that's the polynomial we end up with. So let's recap what we did in this problem. What did we do on this problem to begin with?
We found the coefficients
Before that,
of the terms.
we figured out how many terms there were. How did we do that?
One exponent plus 1.
1 to the exponent, so that means I've got 8 terms. Okay, then to start with the coefficients, what did we do to begin with? We know the outsides are 1, and then we know the next two are whatever your exponent is. Okay, then I labeled these two right here, and I used my fractions to figure out what those were. Once I had these, they automatically mirrored over here. Once I have that, then I went to the first one, did all those. I went to the second one, did all those. Then it's just a matter of multiplying everything and putting it in order. So that's expanding a binomial using the binomial theorem without having to use Pascal. Questions? Okay. Alright, page 633, 12 to 22 even, and then 36 and 38. 36 and 38 are the ones that you're going to expand like the last problem. 12 through 22 is where you're just finding the coefficient.